guys, we were talking about if statements. If statements are actually pretty clear, aren't they? There's really three forms, or at least the book, the text, says that there's three forms. And that's if you use if all by itself, in which case you're just doing if condition is true, do something. If hungry, eat, you know. There's not even an else. Use the second format for problems where you want to do one thing or another. If sick, go to doctor, else go to work. Two different things, if, else. And then use the third format, if, else if you have like three or more choices. And that's what our homework was. Several of y'all have already turned it in. And that's what the freezing assignment was. You know, if something was true, it was boiling. Else if something was true, it was freezing. And if none of those were true, then it was liquid. And anytime you have a series of if, else ifs, it's a good idea to go ahead and put a trailing else just to scoop up any possibility that there was a mistake. And I'll show you what I mean by that. Suppose we had done our freezing boiling program like this. If temperature is less or greater than 32 and temperature less than 212, print liquid. Else if temperature is less than 32, print frozen. Else if temperature greater than 212, print boiling. Now this is not actually proper logic. I mean, it's close. You could fix it just with a couple of changes. But what's wrong with it?
32 and 212.
Exactly. We're not checking for 32. We're only checking to see if something is greater than 32, and then later on we're checking to see if it's less than 32. And the same thing, we're only checking to see if something is less than 212 or if it's greater than 212. But if it's equal to 212, we're not going to print anything. You know, and we could just test that on our heads. Say the temperature was exactly 32. Now, in my mind, I'm not sure whether we should print liquid or frozen at 32 anyways. But our temperature is exactly 32. Is this first case true? Is the temperature greater than 32? No, so we can't print liquid. Is our temperature less than 32? No, because it's equal to 32. Else if temperature is greater than 212? Nope. Okay. So that's broken logic. It wouldn't print anything. We could catch that error really fast, though, in a program if we had one more else case. Print temperature unexpected result. And just to be sure, we might actually print the temperature out. You know, error temperature. Something like that. Something that clearly denotes that this is an unexpected state. Now, you don't have to do that if you already had a dangling else already. And the way we structured our logic in the other day, we didn't need to have a dangling else. We already had one. We did this. If temperature is less than 32, it's liquid. Else, if temperature is greater than 212, it's boiling. Else, I did that wrong. What should that be?
Freezing.
Yeah. Why did I do that? Okay. Else it's boiling. Else it's liquid. There we go. So we already had a final else case. It's going to do one of these three choices no matter what. There's no way for it to weasel its way through here without doing one. But this one didn't have a final catch-all else. So it could get through there. So if you want to make sure that you have all conditions accounted for, I mean, you know, maybe it's really okay for it to go all the way through and not hit any of them. You know, for things where you're not picking from a set and you have to pick one, you know, it's okay to get all the way through without printing something. But in this case, it's not, because It should be one or the other, ignoring the fact that people call plasma, you know, a state, and then they might call superconductor when it hits absolute zero another state. Okay, we're getting off technical. But realistically, or at least as we defined it, we only had 3 states. And so we wanted to print an error message if that state was not hit. So you can see that there's more than one way usually to write a series of if-else ifs. You can kind of change the order of them. You can make the cases differ. You just want to pick the one that makes the most sense to you and is the least error prone. This one's kind of error prone. The logic is a little more complicated because it has an and here, you know, and we're checking. We have these boundary conditions in 2 places, not just one. We have 32 there, and we have 212 there and there. So this one's the simplest one, although we could have reversed less than 32 and greater than 212 just as easily, and it would have worked. Okay, so the 3 forms of ifs. If, do something. If, do something, else, do another thing. If, do something, else, do another thing, except that should be else if, and then a final else, do yet something else, do a third thing. And of course, after the word if comes your case. I shouldn't call it case because there's an actual keyword called case. If condition. There we go. So practice problems. Whip out Notepad or Word or something. You can just come over here and type Notepad if you don't see it here, or you can launch Word or something. And we're going to do these sample problems. Write an algorithm that prints warm if the temperature is above 50 degrees and cold otherwise. Well, I'll do that one with you. And when it says write an algorithm, that doesn't mean you have to code it in C. Just do it kind of like I did here. Use the word print. You can leave off the parentheses if you don't want to put them there. This is what's known as pseudocode when you're not really following any specific task. Okay, so if temperature is above 50 degrees, we're supposed to print warm. And then it prints cold otherwise. Now in our homework and in our in-class assignment, we did it a little bit more complicated. We had a variable called state, and we said state is equal to frozen, state is equal to liquid, state is equal to boiling, and then we printed it out. But this is the simplest expression of that. Alrighty, the second one's even easier because it's just a single if without even an else. Write an algorithm that prints no school if temperature is below 10 degrees. Now if that's 10 degrees Celsius, that's a pretty generous stay home policy. Because 10 degrees Celsius to Fahrenheit is 50 degrees Fahrenheit. I want to stay home if it's less than 50 degrees Fahrenheit. That sounds good to me. Okay, so if temperature is below 10, print no school. Then the last one. Write an algorithm that prints too cold if it's below 50, okay if it's between 50 and 90, and too hot if the temperature is above 90. Now there's more than one way of doing this one, so I'll just let you pick one in your brain and then I'll illustrate one. It might not be the same, but that doesn't mean yours is wrong. the way this last one is structured, it's got one of those AND clauses. You could write the logic exactly as it's given here, in which case you would put an AND. But you could also structure this in such a way that you didn't need to use AND because your final else handled that condition. So, writing it exactly as it's written. If temperature is below 50, we print too cold. Else, if temperature, and I'm writing it exactly the way they did, is between 50 and 90. Now that's a little bit tricky. If temperature is greater than and equal to 50, and, or you can use the and signs, temperature is less than or equal to 90, and that's kind of obnoxious doing it like that, but we're doing it exactly as they printed it. Print OK. Else, if temperature is greater than 90, print too hot. Else, my rule of thumb is to always put a terminating else if you have a series of else ifs. Print, I have no idea. Whatever, some kind of warning message. We could have left this one out and it would match this logic exactly. But that is not the simplest expression of that logic. What would be a simpler expression? So I'm sure that somebody did it without using an and statement in it. Did any?
First else if, and then put the OK in the else.
Yeah, let's do that. If temperature is less than 50, print too cold. Else, if temperature is greater than 90, print too hot. Else, print OK. Now that's simpler. So we took this logic and we applied our programmer brain to it and came up with a simpler expression than what the non-programmer who gave us the specs for the project gave us. Both are valid, but usually the simpler looking the code is, the quote cleaner the code is, the better it is because it's easier to maintain. There's less likely that you made a little mistake. Here, if I hadn't have put these equal signs in it, then there would have been a problem. You know, and when you're dealing with these boundaries, you know, this would also be valid. If temperature is less than or equal to 49, else if temperature is greater than equal to 50, else if temperature is greater than or equal to 91, that would be valid, except if you were dealing with a floating point number. Because what if it was 49.9? So I took some good logic and then just by trying to illustrate something, I don't know what I was thinking, I made it broken. This would work for integers, but it would not work for floating point numbers because my boundary conditions, the cases where you're flipping from one to the other, have a problem in them. That's why this one's better. It's simpler. Notepad only allows one undo, which is annoying. So really when I'm doing these things, I ought to do them in Word. But then Word starts underlining all my typos and stuff, and it annoys me. I don't know if anybody ever goes back and looks at these notes. You probably will, hopefully, when we have more homework. They're there. Usually everything I type, I upload. It may not make a lot of sense without the context of the lecture, but hopefully, you know, at least ring some memory cells. Here's what I go about, you know, the boundary cases. By the way, one of the test questions, I'll go ahead and give it away. See if you remember it when the test comes around. Is the logic is something like this. If grade is greater than or equal to 90, print A. No, but there's no else. If grade is greater than or equal to 80, print B. If grade is greater than or equal to 70, print C. You get the idea, so I'm going to stop at that point and just say that if you didn't make a C, we're real jerks around here and you make an F. Okay, so ignoring the fact that this doesn't allow you to make a D, is this good or is this bad? Is this, and if it's not good code, what's wrong with it?
It needs to be if else.
It does have to be else. Why is that? Because what would happen if you made a 99? It would print A, then it'd come down here and go, oh, well, is grade greater than 80? It sure is. You also made a B. Else if grade is greater than 70, yeah, you made a C. And so it would print ABC. Or worse, if we use that grade variable, you know, where we said grade is equal to A, and then we said grade is equal to B, and then we said grade is equal to C, and then we printed the grade at the bottom, it'd print C. So the only the only grades that these would be valid for would be C's or F's, not A's or B's. You'd never get an A or a B as your output from that. And you would correct it by putting else's. What's wrong with this code? It needs else if, or L, because if you entered a 99, it would print A, B, and C. Without using the else's, these are not, quote, mutually exclusive. And you want these to be mutually exclusive in this case. Now, not every series of if statements needs to be mutually exclusive, but in this case they are. So flowcharts. We're not going to do a lot of flowcharting in this class. That was 1113. But flowchart symbols. Oh, and see, I totally disagree with how they're saying it anyways. Forget this. We'll talk about flowcharts later when we come in with... All right, I'm getting an itch to do this. Somebody stop me. All right, we're going to do a flowchart for that too hot, too cold, or okay. And I'm going to use a program called Lucidchart to do so. There's also a program called Visio on all of the school machines, but Lucidchart is available online, so it'll work regardless of whether you have a Mac or Linux or whatever. You know what, I should just draw up here. But it's so much prettier if I use a program. Okay, so several different symbols are important to us. There's the rectangle. There's the diamond. And there is, I don't like calling that a quadrilateral because technically speaking a rectangle is a quadrilateral, but I can't come up with a better name for it.
A rhombus?
Rhombus, but technically these are rhombuses too.
A parallelogram.
Technically these are all three. They're parallelograms. Well, the diamond's not necessarily. Okay, but yeah, we'll call this the parallelogram. We'll call this the diamond. And this is the rectangle. This one you use for a directive statement like math calculations. A is equal to A plus 1. C is equal to 7. That kind of thing. The diamond is used for decisions like if, or later on, while. And the parallelogram is used for input or output. So either print or input, but in Java, we're going to call this a scanner. We use the scanner.next to get input and output. So to do that less than 50 and greater than a 100, I'm not going to do any calculations. We're going to pretend that we already have our temperature. But I am going to have some decisions, and I'm going to have some print statements. So let's get our code up on screen for that. The simplest version of it is here. There we go. If I'm just going to call it T though, rather than temperature. If T less than 50, then come over here and print too cold. See, the reason I should do it on the computer program is because you can't read my writing. I can't either. Else, if temperature is greater than 100, print too hot. And really I would put the word print on it as well, but you get the idea. So I'm going to put true here because it goes that way if that's true. Else it goes that way. Else if temperature is greater than, finally we have one last else, which is to print OK. Now all this stuff has to hook back up. I'm not liking the way this looks. That's another true. And this is a false. Okay, that looks really bad because I don't like joining these different paths that way. But really, that's the way you have to do it, although we're going to look at the PowerPoint and see if that's correct or not. And why do I say that? Because if it's too cold, there's no reason to go back and do this if statement. You could draw a line there, but really it's never going to get there. So why did I want to talk about flowcharting? Anybody have a suggestion? Those who have taken courses with flowcharting before, is there a better way of doing this one?
I hated flowcharts.
Yeah. Yeah, I make the poor 1113 students spend a lot of miserable time doing flowcharting. I can't come up with a better way for this. You could put the word else if right here, but that's not strictly the right way to do it.
Yeah, it looks like the PowerPoint, they didn't come up with a better solution either. It's just more of a staircase.
Yeah. And what you find as you look at flowcharts more is that programming languages have long superseded flowcharts. They use programming constructs that flowcharts don't really support. All right, they just did a stair step. You're right. That's how they did it. And again, they had all three ways hook up at the bottom. So just about exactly what I did. It was, the lines are in a different direction, but same idea. They didn't use the word else anywhere, but which I disagree with. I think it ought to have else in there to indicate that when you program it. Anyways, and this is almost kind of trivia, or not trivia, but you could write it like this. If temperature is greater than 100, this time let's put braces everywhere, just to make it look. Print hot. Else, if temperature is less than 50. Print cold. Else print. Okay. You don't need to do it that way. I don't recommend that you do it that way. If you're going to have an else if, don't put a brace here. But it's perfectly valid logic, and it actually looks a little bit more like that flowchart than just a series of if else ifs did. I honestly can't think of a reason why you would do it this way, especially in this particular problem. If there was something that needed to happen before this decision could be made, like we wanted to print, yay, it's not too hot, then yeah, that's valid. But if there's nothing there, if you have an else and then you have a brace and then you have if there, just fine, get rid of that. Let's add a comment that this is really kind of a dumb way to do it. Not so great way of structuring it. So flow of control, that's the order in which a program's statements are executed. Well, aren't statements always executed top down? Not really. If you have loops, then you can go back and you can execute stuff again. Or if you've organized things in a module, then they may not be in the correct order of what you might think at all. Okay, we're going to change this program so that this is the water program we used. We're going to change this program so that it actually asks for the temperature in a different place. We're going to add on a method so that it not only has a main method, but it's got one called getTemp. And kind of ignore the fact that I tacked on the word public. That's actually not necessary. And the word static and the word int there. We'll get to why all that's necessary. But for now, just take it on faith that a module is a block of code with a name on it, so that it can be invoked more than once. Okay. If I didn't make any mistakes, this program would compile and run. To get it all in one screen, I'm going to remove these braces. I strongly recommend you put every brace you possibly can in your code, but I'm leaving them out just to try to get all of this code on one page. Okay, here's what I mean by code not necessarily running in order. The main method is always what's executed first. The Java runtime engine finds a main method of your code, and execution starts there. So in general, in a block of code, execution is top down. So it would declare a variable called state. It would declare a variable called temp, and then it invokes the getTemp method, which you Python users were calling functions. So it runs down here now. It's like telling somebody else to go get the temperature. So this function then it creates a scanner so that we can read from the input. It prints a message, what is the temperature? It gets that temperature, and it returns it. Return means that it goes back to where it was called. It's kind of like here we told somebody else to get the temperature. Well, they wrote the temperature down and they handed it back on a note to us, and that got stored here. And then we could go ahead and print. So you see, the order wasn't strictly top down. We did a couple of things. All of a sudden the code's down here running, and then it jumps back up, and I could run it in the debugger and we would watch that. Let's see if we can get that going. I'm going to click debug file. I forgot to set a breakpoint though, so it's just going to run through the entire file without pausing. When you run the interactive debugger, if you have a breakpoint set, which you do by right-clicking, then it puts a little red mark there, and that means that when you run it in debug mode, it will stop at that point, and then you can execute it line by line. So now I'm going to click debug file. What happens is Java jumps to the main. It's already done that. It's already done that. For some reason, the debugger didn't want me to set a breakpoint on either line 17 or 18 because they're not actually executable statements. They're just creating variables. Here we are. We're at this point. I'm going to go to the next line. Whoops, now we're down here. Now we're down there. Now we're down there. Now we've got the temperature. It's asking for the temperature and we need to type something in. So I need to go to the output window and it says where's the temperature. I'm going to type in 100. I'm going to type in 60. Okay, now it's ready to return to temperature. So now we're back here. And that number that was typed in down there, 60, is stored into the temp variable. We can actually see that if we go over here. One of these is called temp. We see that it's got the value of 60 in it. Now we're at, if we click next again, it went from here, was the temperature less than 0? No, it was not because it's 60. So now it's on this if statement. Is the temperature greater than 100? No, so we know what it's going to do. It's going to skip that line as well. Instead, it bopped down here, and since it was 60, it was a liquid. And it set state to liquid, and then we print out our final answer. The water is state. Now we're done with the program. And so it says build successful. And apparently it took me 1 minute and 30 seconds to blather all that. So code does not always execute sequentially, but it often does. There's broadly 3 kinds of code. You could tack on a 4th one, which is the invocation of a method, another block of code. But ignoring that, there are sequential statements which are executed one after the other. Math calculations, print statements, input statements, all of those just go in line by line. That is like, that's if you have a straight line in a flowchart. That statement is sequential to that statement, and that statement is sequential to that statement. Then there are branching statements. Branching statements are when things can go in more than one way. Here, for example, if this is true, it prints too cold. And then it goes down to the bottom of the structure. Else, it goes and it does another if. And if that's true, it prints something else. So each one of these diamonds represents a possible branch. And we can see that in our code. These are branches. If this was true, it executes that one. And then it jumps down past all of the if-elses. Else, if that one was true, it doesn't run that one, but it runs that one, and then it jumps to the end of all the if-elses. And then lastly, if neither one of these were true, it runs that one. Just like we had 3 different possible branches from our if statements in the diagram. So that's another kind of flow control. You have sequential, you have branching statements, and then you have loops. And we haven't really seen examples of loops. Maybe I threw one at you. We haven't seen any PowerPoints. That just looks something like this. Int x is equal to 0. While x is less than 100, x equals x plus 1, print x. This is a loop. As long as this condition is true, while this condition is true, it's like an if statement. If the condition is true, it goes ahead and executes those two lines, but then it repeats them. It checks the condition again, and as long as it's still true, it repeats it again, and then it repeats it again. So this loop is going to go until x is no longer less than 100. I'm going to change the order of these. It's kind of confusing me that I'm increasing the value of x before I print it out. So this would print out the numbers 0 through 99. Why do I say that? Because when x is equal to 100, is this condition true? If x is 100, well, here, let me just set a breakpoint here. We'll run it. Get rid of that breakpoint. And you're saying, all I did is want you to repeat the question. Okay, here we go. So we run the debugger. It comes down to here. Right now, right, we're running the debugger. Oh, what is the temperature? Yeah, we have to do all that first. Okay, the green line is the line that we're currently at. X is equal to 0. Is x less than 100? It is. So it's going to print x, and then it's going to add 1 to x and store it back into itself. So it prints x, x is equal to 0. It adds 1 to x. So now if we hover our cursor over x, x is equal to 1. Is 1 less than 100? Yep. So let's just say that we kept doing that. When x is finally equal to 100, when it prints x is equal to 100, is this condition still true? No, it's not. So it's going to stop. It's going to no longer execute the code of the loop. We can say it exits the loop. Now that's obviously going to take some time. So I'm just going to press the green arrow, which means run until the next breakpoint. And since there aren't any more breakpoints, oh, there is a breakpoint here. Let me get rid of that. There. It ran all the way, so it didn't print out 100. If I wanted it to print out 100, I should have made it x is less than or equal to 100. So that's a loop. That's the second category. No, that's the third category. Sequential, branching, and loop statements. Right now, the only kind of branching statement we've seen is an if statement. There's another one called a switch, which we'll talk about later, so I'm going to put that in parentheses. And then for loops, I just showed you while, but there's another kind of loop called a for, which we will talk about later. And another one called do, or do while, which we will talk about later. But I do want you to know, broadly, math calculations, print statements, input statements are all sequential statements. Variable declarations, they're sequential. All right, now we've hit while. Here's their way of drawing a while loop, and I agree. This is a good way of drawing it. Except I would have put the print statement in a parallelogram. Set the counter to 1. Is counter less than or equal to 100? Yes, it is. So print happy birthday. We're really annoying. We're going to tell the person birthday 100 times. We add 1 to the counter. We come back up here. Now, so when I do flowcharts, if it's a decision block, I go ahead and put the word if in it, or the word while in it. Why make it slightly more challenging to figure out what that is? So anyways, this is while count is less than or equal to 100. It keeps incrementing, it keeps printing happy birthday. When the counter gets to 101, it goes here, is 101 less than 100? No, it is not, so it exits the loop, and it comes and does whatever's at the end of the program. So an if statement has 2 branches, and then they rejoin somewhere at the bottom. But a while has 2 branches, but 1 loops back up to the while again. the yes side, and the no side just goes on. The number of times that the loop repeats is called the number of iterations. Sometimes you don't know the number of iterations in advance. Why would that be? What if we made our program say, do you wish to go again? You don't know how many times they're going to keep saying, do you wish to go again? They might just say once, they might do it twice, or maybe they're obsessive compulsive and they never stop it. So, but in this case, when we had a counter and it was going from 0 to 99 or 1 to 100, that was the number of iterations. We knew it in advance. Sometimes you don't know the number of iterations in advance. Or what if you were writing software for a toaster and you just kept checking the toast, and if the toast was brown, you had some kind of visual sensor, then you pop the toast. You wouldn't know how many times, to keep looping, how many seconds to wait. Actually, probably that's not the way toasters work, but that's kind of the way we think about things. If you have a marshmallow in a fire, is marshmallow burning? Yeah, it's time to take it out. We don't really know how long we're going to keep it in there. We don't know how many iterations. Write an algorithm that prints happy birthday 5 times. Alrighty. Set counter to 1. Again, this is pseudocode. We don't use a set statement. We just say count equals 1, or int count equals 1. While count is less than or equal to 5. And I don't mind using math symbols, less than, equal. Print happy birthday, and then set count to count plus 1. That would print out happy birthday 5 times. What is tracing? Tracing is when you execute the algorithm line by line, carefully recording everything that happens. Meaning you grab a piece of paper or a spreadsheet. Now really it's easier just to run a debugger and let it execute it line by line. But tracing things line by line is something you will eventually wind up doing when your program is hitting some weird state and you can't figure out what it's doing wrong. Now, he doesn't give us an example of something to trace, so I'll write one. X is equal to 100. Int y is equal to 30. While x is, gosh, I'm not coming up with a good example here. Let's do an interest program where we repeat an interest calculation until the user has earned $100 in interest. So we're going to declare a variable called principal, which is the amount of money we have. And then we're going to declare a variable called rate, which is the amount of interest we earn, 10%. And now we're going to have a while loop. While the principal is less than or equal to $1,000, then we're going to increase, let's also put a year counter. Int year is equal to 1. So we're going, after that, we're going to add, let's calculate the interest. The interest is equal to the principal times the rate. Then the principal increases by the amount of the interest. The year increases by 1. So let's actually start year at 0. And then we're going to print it out. system.out.println the year plus a space plus the principal. And if I did that right, I'm going to comment out this freezing, boiling stuff. That's really not applicable to this program anymore. Neither is printing out 100 different numbers. This shows us that at a 10% interest rate, it takes 25 years for your initial investment of 100 to hit 1,000. Let's change these variables and then trace it by hand. Now we have 50% interest. We must have invested in Google or something. Let's figure out by tracing how many years it takes to hit $1,000. And we may set our threshold lower if we get bored of doing this. You're saying I'm already bored with it. Sorry. Okay. So our variables are, we have a variable called principal, we have a variable called rate, we have a variable called year, which I'm just going to call Y for ease of sake. And then we have one that pops up periodically called interest. Can I make straight lines? No, I cannot. All right. So we start off, line 18, the principal gets assigned to 100. Line 19, the rate gets set to 0.5. Line 20, the year gets set to 0. Now I could keep writing this. Oh, he's still 100, isn't he? He's still 100, is he? Or I could just say, unless it updates, I'm going to leave it blank. Alrighty. So, is principal less than or equal to 1,000? It sure is, because it's 100. So now, interest is equal to principal times rate. What is half of 100? That's a rough one. Anybody listening?
Sorry, I was typing.
If we multiply 0.5 times 100, half of 100 is 50. And that happened on line number 24. So what happens in 25? Principal is increased by the amount of the interest. What's our new principal value? It's 150. And then 26. Year is equal to year plus 1. So year becomes 1. You know what, this is going to take quite a while to hit 1,000. Let's just do it to 300. Line 27, we print it out. So we print out 1 and 150. Then we loop back up here. Is principal still less than or equal to 300? It sure is. So interest is equal to principal times rate. What is half of 150? 75. I'm no longer going to write the line numbers down. Okay, and then principal is equal to principal plus interest. So what is principal now?
225.
Uh-huh. Everybody in agreement? Alrighty. And then year gets one added to it. We print those out. Is principal less than 300? No, it is not. So we loop again. Interest is equal to principal times rate. I don't know what half of 225 is. I'm going to say it's 112. It's actually 112.5. Now, we add that to that, and we get 337. We add 1 to year. We print that out. Now we go back up to the while statement. Is principal less than 300? No, it is not. So, if we ran this, if we made these changes, we should see that it took 3 years for our principal to grow to 100. So we can make that change. Go down to the program here. I changed that to 300. There we go. Let's run it again. Yeah, after 3 years we had 337. That's tracing. I don't think I'm going to actually have y'all do that. I never have asked a class to do that because it's tedious. But I should. I am negligent. You can give me a failing grade on my teacher eval. Alrighty, let's see if we have any cool programming assignments queued up that might be good to make you do over Labor Day weekend. Wouldn't that be a jerky thing to do? Let's go look. What is Chapter 2, Homework A? Write a program that uses a while loop to print all the numbers between 2 and 30, but even numbers only. And then write a program that does the following. Prompt the user for the salary and the years worked. Calculate the yearly bonus. The bonus is calculated by the following algorithm. If the person has worked 5 or more years, they get a bonus. The bonus is calculated by years times 10% times their salary. Otherwise, they receive no bonus. Then display the amount earned, which is the salary plus the bonus. Extra credit. You can make the program loop until the user wants it to stop. B is also worth 25 points. That is okay to assign, I think, but what I'm going to do is not make it due next Wednesday. But since we only have one class period between now and then, make it due the 11th. That way we can talk about it again before it's actually done. With the example while loop that we have, well, it's not in our notes yet, but it will be. The only thing that it doesn't show you is how to make it count by 2s to print even numbers only. I'm going to write a little while loop here. It's going to be a slightly different problem, but count from 10 to 100 by 10s. So int x is equal to 10, while x is less than or equal to 100, system.out.println x, and then x is equal to x plus 1. Now that's not the correct solution. What would we do to make this work? There's 2 easy fixes.
Plus 10 instead of plus 1.
That would be the easiest fix. That would make it count by 10, as long as we had a good starting point. The other thing we could do is use an if statement with a modulus. We have talked about modulus. I'm not seeing a lot of nodding. Okay, that's the C class. Never mind. That's how I would do it in this case. Modulus is a mathematical operator that gives you the remainder of something. So if you divide 11 by 10, what is the remainder? It's 1. So you know that that is not evenly divisible by 10. But if you divide 20 by 10, what is the remainder? 0. So there's a way you could check that operation to see if the remainder was 0. And if it was, you would know it was evenly divisible by 10. But that's how I would do that. This is obviously the very easy part of the assignment. I'm going to go ahead and paste this into the notes. You would have to modify it, of course. The next one is a little bit more difficult. I'm not going to talk any more about it now. We may come back and talk about it next Wednesday. Wait a minute. We have class on Tuesday and Thursday. Well, I'm still going to keep the due date what it is. But you may as well get it done early rather than later. All right, let me move that up into the due section, and we will call it a day. Did I take a roll? I do not believe I did.